ça fait clair, allez, clair.
Easy now, easy. Watch the starboard side.
Pins engaged, we have green across the board.
Okay, the next mounting point is section 7. 7, copy that. Applying the rivets now.
Here, the technicians meticulously route the primary wiring conduits, the nervous system of the eVTOL. Every cable clamp is secured precisely.
Yes, the stress test results match the specifications. Sign off confirmed. Ready for assembly.
Crane, hold position.
Copy that, holding. A little lower on your mark.
Clear left side.
Check the alignment on section 7.
Looks good. Ready for wing integration sequence?
The power integration looks clean.
Yes, the weight distribution is perfect.
We are ready for the next phase.
We are currently reviewing the battery timeline.
This integration point here is critical for the propulsion handover next month.
As the fuselage arrives at the propulsion integration area, the real work begins. The future of flight is almost ready.
Alignment pin 6 is secure.
Spacing verified on the scanner. Tolerance is green.
temperature curve is right on profile.
Yes, the adhesive should set perfectly at this rate.
The battery cells are precisely connected into modules using automated spot welding, ensuring maximum safety and efficiency. The battery modules are secured in their protective casing, ensuring thermal safety through integrated cooling channels.
Fluctuating readings on zone 3 maintain stabilization.
Compensated. Pressure levels are nominal. We are clear for the cycle start.
Stable spin achieved. All parameters are within tolerance.
Confirmed. The vibration dampening is excellent.
Vibration levels are stable across all sensors.
Confirmed. Noise levels are well within the projected limits. The run is successful.
Rotor assembly looks good. Check the torque on housing unit 4.
Confirmed. All parameters are within tolerance.
Excellent. Final gate approval granted.
Here we see the eVTOL airframe during a major assembly milestone, with the wings and rotors now attached. This marks the end of the build phase. Next, the critical systems integration begins.
Okay, ease it in slowly, align with the connector.
Got it. Secure the locking mechanism.
The readout is stabilizing at neutral.
Verified. Locking in the setting now.
System B has assumed control. Check the voltage regulators.
Confirmed stable. The failover was successful.
Test sequence initiated for continuity.
We have full continuity on all channels. Logging results now.
Ground power connected and full system power-up initiated. Screens, sensors, and motors responding in sequence.
Rotor array synchronization is holding steady at 90 degrees.
Confirmed. Data logs are clear.
Rotor speed stabilizing at 20%.
All readings nominal. Clear for duration.
As you can see on the heat map, the motor temperatures remain stable during the high load operation.
Confirmed. All systems are green.
Emergency shutdown complete. Rotors stabilized.
Simulation passed. Well done. Section 4, fuselage fasteners.
All within tolerance. Reading confirmed on the tablet. Can you check this section here near the joint?
Running the light over it now. Looks clean, but let's double check the tolerance.
Power levels holding steady at 40%.
Confirmed. Rotors engaging smoothly.
All parameters are met. The certification is approved.
Confirmed. Signing off now. The successful rollout marks a monumental step forward for urban air mobility in Dubai.
The rotor alignment is perfect.
Indeed. The team did excellent work.
With the $3 million eVTOL ready for launch, the skies of Dubai will never be the same.